Hello students, welcome all of you to the Learn Chemistry channel. In today's class I should discuss about chemical equilibrium. Chemical equilibrium is one of the most important topics in physical chemistry. For board level it is in class 11, but it is very important in competitive level also. As I told you earlier, I will deliver the lecture in Bengali as well as English, but at the time of writing I will write in English only. অনেক বাংলা মিডিয়ামের স্টুডেন্ট আছে যাদের কথা ভেবে আমি বাংলাতেও বলবো যাতে তাদের লেকচারটা বুঝতে কোনো অসুবিধা না হয়। কেমিক্যাল ইকুইলিব্রিয়াম its meaning, Bengali meaning is রাসায়নিক সাম্যাবস্থা। Applicability, applicable for reversible reactions. Look at the reaction CaCO3 on heating gives you CaO plus CO2. CaCO3 was solid, CaO was solid, CO2 was gas. When CaCO3 was heated in an open container, CO2 leaves the system as gas. Hence, to maintain equilibrium constant unchanged, more CO will be obtained. Ultimately, only CO will be left behind. যেহেতু এটাকে খোলা পাত্রে উত্তপ্ত যদি করো, CO2টা গ্যাস হিসেবে বায়ুমণ্ডলে চলে যাচ্ছে, অবশেষ রূপে শুধু CO পড়ে থাকবে। Look at this reaction also, NaNO3, NaCl plus AgNO3. Both of them are liquid. It form AgCl as Cardi white PPT. White PPT plus NaNO3, double displacement reaction. These reactions are not reversible, it is irreversible reaction. One direction, reactant gives you product. But look at the reaction, N2 gas plus 3H2 gas. These two are reactant. This gives you ammonia as a product. In this case, reactant combine together to gives you product ammonia. After certain time, when ammonia accumulated to a large extent, ammonia decomposes to gives you nitrogen and hydrogen. So the reaction never complete. It is an example of reversible reaction. Now, suppose it is the concentration, it is the time. Reactant concentration decreases with time, A to BC. From A to B, concentration of the reactant decreases with time, but from B to C, time changes because it is a horizontal line parallel to the x-axis. Concentration of the reactant doesn't change. That means after a certain time, the reactant concentration doesn't change further. Suppose it is the product one. In this case also, from D to E, it is a product. Concentration of the product doesn't change with time. Hence, we can see at the point here, the system has attained equilibrium. So, no change in concentration of reactant and the product with time. At equilibrium, concentration of reactant and product does not change with time. Now, expression of equilibrium constant. First of all, Reversible chemical equilibrium are of two kinds. One of them is called homogeneous. It is heterogeneous. Homogeneous means when reactant and product are in same phase. বিক্রিয়ক এবং বিক্রিয়াজাত পদার্থগুলো কি হবে, একই দশায় থাকবে। লিকুইড তো অল লিকুইড, গ্যাস তো অল গ্যাস। In heterogeneous equilibrium, it mostly composed of solid and gas. Solid never be the part of equilibrium. Now I will explain these things, homogeneous and heterogeneous, in the next page. Look at the reaction. To NH3 gas. In this case, equilibrium constant, that the point when the concentration of reactant and the product doesn't change with time, can be represented by the word Kp. P means pressure, and reactant and the product are expressed by partial pressure. It is product. On the numerator it will be pressure or concentration of the product, denominator will be pressure or concentration of the reactant. All of them should be expressed by partial pressure. So I can write it PnH3 square Pn2 into PH2 cube. The coefficient goes to power. If it is the case of a liquid, in this case it will be Kc. Kc will be what? Product. Third bracket means concentration or active mass. It's better to call it as active mass. It will be CH3, COOH. Okay. Now, suppose a particular reaction, if it is in gaseous state, it will be Kp. When the reactant and the product are expressed by partial pressure. When it is in liquid state, it will be Kc. Reactant and the product are expressed by partial concentration. Then what is the relation between Kp and Kc for a particular reaction? Relation is Kp equals to Kc RT to the power del N. Del N means difference between the moles of product and reactant. Suppose look at the reaction. In this case, del N, moles of product is 2, moles of reactant is 1 plus 3, 4. Del N will be 2 minus 4, that is minus 2. Hence, for this particular reaction, Kp is equal to Kc RT to the power minus 2. Look at the reaction, another one. In this case, del N is equal to 1. All of them are gaseous state. Kp equals to Kc RT to the power 2 minus 1, that is 1. For the reaction, moles of reactant is 2, product is 2. Del N is equal to 0. Hence Kp is equal to Kc RT to the power 2 minus 2, 0. Anything to the power 0 is 1. So Kp is equal to Kc. Hence, for a particular reaction, when moles of product and reactant are same, Kp is equal to Kc. On the other hand, when del n is positive, we know Kp equal to Kc RT to the power del n have some values. In this case, Kp equals to Kc RT to the power del n. When del n is positive value, so in this case, Kp should be greater than Kc. Now, we know Kp equal to Kc RT to the power del n. In this case, when del n is positive, we have Kp greater than Kc. When del n equal to negative, Kp less than Kc. When del n is equal to 0, Kp equal to Kc. This is important for competitive point of view, because you know, if del n is positive, Kc multiply with something gives you Kp. Hence, Kp should be greater than Kc. R is universal gas constant. T stand for temperature in Kelvin. Now, suppose, look at the reaction H2O2 plus 2H plus 2I minus gives you a 2H2O plus I2. This is the overall reaction. This reaction can be decomposed into 3 reactions. Let the equilibrium constant for the reaction supposed to be K. Let us write the reaction this way. Listen this, it is very, very important one what I am discussing now. Equilibrium constant for this reaction will be look at another reaction. In this case, let it be called as K1. It will be K2. Write another equations. In this case, H2O2 I have written. Third equation will be HOI plus H plus I minus gives you I2 plus H2O. In this case, K3 is equal to I2 into H2O over HOI into H plus into I minus. If you add, suppose it is equation 1, it is equation 2, it is equation 3. If we add these 3 equations, you should get the overall reaction which is given over here. I am just showing it to you. The equation was this. First equation is written as second equation was third equation we have written as what? I2 plus H2, okay? Now add these 3 equations. What you are getting on adding these 3 equations? H2O2 plus I minus plus H plus OH minus plus, I am writing in the next line, HOI plus H plus I minus gives you what? I2 plus H2O plus H2O plus OH minus plus HY. These get cancels, gives you H2O2 plus I minus plus 2H. I minus plus I minus, 2I minus and 2H plus. It is same, but underline with another color such that you can follow it properly. It is see, this is remaining, this is remaining, this is remaining, this is remaining. These are the reactant. In this case, I2 is remaining, A2H2 is remaining. Now, if I write the equilibrium constant, all these three equations, what we are getting? Let us write with black only. K1 is equal to OH minus HY H2O2 into I minus into K1 into K2 into K3. K1 is this, K2 will be what? H2O over H plus into I minus into what it is remaining, I2 into H2O over HY then H plus into I minus. On multiplying these things, what we are getting? On multiplying these things, you should get, on the numerator, we should get 2H2. You see, 2H2 we are getting, I2 we are getting, OH minus and HY, OH minus and HY are cancelled by OH minus and HY present over here. HY is over here, HY is present over here, and OH minus is also there, so they are getting cancels. In this way, we can say when an equation is obtained by the addition of 2 or 3 equations, the overall equilibrium constant will be the product of equilibrium constant of the 3 equations. Okay, in this case a bit mistake I have done, it will be OH minus, I have written it I minus. See, second equation H2O into H plus into OH minus. See, OH minus and HY get cancels, OH minus and HY get cancels. Ultimately what is remaining? I2 is remaining, H2O square is remaining. Denominator what we are getting? Denominator we are getting as H2O2 H plus square into I minus square, because both I minus into I minus square. So K for the equilibrium constant of this equation will be is equal to K1 into K2 into K3. Very important. For addition equals to multiplication of the respective equations. In case of subtraction, equivalent to division of respective equations. I am giving another one when we should think of the case of division. Let us look at the reaction. 2H2O gives you 2H2 plus O2. Suppose it is K1. On the other hand, it is given as it is K2. Now if I reversed it, what it become if I write it this way? On reversing an equation, equilibrium constant is also reversed. So it becomes 1 by K1. If I add this to what we are getting? 2CO2 plus 2H2 gives you what? 2CO plus 2H2O. For this equation, if they ask you what will be the equilibrium constant for the reaction, CO2 plus H2 gives you CO plus H2O. In this case, all the terms are multiplying by 2. So in this case, it will be K2 by K1. This coefficient goes to the power K2 by K1 to the power 2. So if I know the equilibrium constant of these equations, the equilibrium constant for the reaction which is obtained from the above two equation will be K2 by K1 square. K2 by K1 square, because the coefficient goes to power. In this case, it will be K2 by K1 square. Is it clear? Now, I have discussed when an equation is obtained as a sum of 2-3 equation, overall equilibrium constant will be the product of respective equilibrium constant. On the other hand, if it is a case of your division, in this case it is a case of your subtraction, as I told you. Now, I should come across a very important concept in chemical equilibrium, that is called degree of dissociation. It is denoted by the word alpha. Moles decomposed at equilibrium over moles taken, initial moles. Look at the reaction. Suppose we have taken 1 mole, 1 mole. Product is 0. If alpha mole of SO2 decomposed at equilibrium it will be 1 minus alpha. It will be 1 minus alpha by 2. Why? Because for every 2 mole, 1 mole of the react, 1 mole of them react. 1 minus alpha by 2. Because of the 2, alpha mole will be formed over here. In this case, what will be the degree of dissociation? Alpha by 1. Moles decomposed. Out of 1 mole, whatever be the moles taken is 1, will be the degree of dissociation. Let us take another equations. Look at here. I am taking another equation for your understanding. Same equation I am taking. Two. In this case, it is 1 mole. It is 1 mole. It is 0. Suppose 2 alpha mole decomposed over here. Because for every 2 moles, 1 mole of them react. In this case, degree of dissociation will be two alpha by 1. That is 2 alpha. Suppose third case and the last case. Let us take this another equations for your understanding. Suppose we have taken it N2 plus 3H2 reversible sign 2NH3. Suppose we have taken A moles over here, 3A moles over here. A moles and 3A moles we have taken. So, suppose for 1 mole alpha mole react, alpha is the degree of dissociation. What does it mean? For 1 mole alpha mole react, for A mole, suppose A alpha mole react, A minus A alpha, whatever be the moles of nitrogen react, hydrogen require 3 times of that, 3a minus 3a alpha. It will be 2a alpha. So what will be the degree of dissociation out of a mole? A alpha mole reacted. So degree of dissociation will be, in the third case, moles taken how much? How much mole decomposed? A alpha. How much mole we have taken? A. So degree of dissociation is same as alpha. It is very, very important concept how to find degree of dissociation. 3 cases I have discussed. It will take into account of all kind of dissociation, which all cases which you come across in deriving degree of dissociation. Suppose, look at another equation. 2NH3 gives you N2 plus 3H2. If the equilibrium constant is K1, if all the terms was divided by 2, what it will be? NH3, reversible sign N2 by 2 plus 3H2 by 2. That means the earlier one, the first equation, it was K1. In this case, half of 2NH3 N2 plus 3H2. In this case, what will be the equilibrium constant in terms of K1? As everything multiplied by K1, it will be K1 to the power half. The coefficient by which all the reactant and the product are multiplied goes to power. Okay. On the other hand, if you reversed an equation, what will be the equilibrium constant? In this case, suppose if I write it N2 plus 3H2, reversible sign 2NH3. In this case, earlier equation was K1. On reversing it, it becomes what? 1 by K1. In this way, knowing the equilibrium constant of a reaction, you can find out the equilibrium constant of other reactions. Okay. Hope you will make your concept clear with the things what I have discussed so far. Chemical equilibrium is a long topics. Later on, I will discuss some of the application of your degree of dissociation in defining equilibrium constant, Lassalle's principle, etc. Thank you for today's class.